Welcome to Physical Computing, a curriculum development proposal for grades 9 through 12. What is physical computing? It is the sensing of a physical condition, usually based on the human senses, to be converted to an electrical form that can be understood by a processor that will respond with an electrical output to some desired device or condition. This is illustrated by the example shown. A sensor picking up a rise in temperature that is processed to turn on a fan for cooling. This paper is based on the premise that offering a course in physical computing can contribute to the STEM initiatives that could help our country to recapture its leadership in engineering and in the technologies of the future. It is also premised to contribute to the critical and creative thinking skills that our young people will need for the challenges of tomorrow. Chapter 1 concludes the introduction with an overview of the rest of the paper. Chapter 2 of this proposal covers the literature review to support it. Research was done on STEM, on physical computing, and on critical and creative thinking. Some of the acronyms noted are PCAST, President's Council of Advisors on Science and Technology, FCR, Florida Center for Research, FDOE, Florida Department of Education. Chapter 2 also gives a few research definitions of physical computing from some of the leading experts in the field, as noted. In summary, they note physical computing to be pervasive, ubiquitous, wearable, and invisible. In the research on critical and creative thinking, several comments were found to support the harmonious relationship between the two. The similarities and differences from the literature are noted in Chapter 2. Chapter 3 covers the methodology for the proposal. The objectives for this proposed curriculum are 1. To demonstrate the physical scientific laws of electricity, electronics, and mechanics in representing physical conditions and actions, and 2. To generate solutions to problems and questions about physical human-computer interaction. Chapter 3 also includes a discussion on how educational standards will be addressed in this course. The study of physical computing is built around a small example of artificial intelligence called a microcontroller. Pictured here is the Arduino module used as this small brain. The Arduino is an example of many such products on the market. It was used in the research for this proposal. It is programmable so as to take an input and process the predefined and desired output, as noted in our earlier temperature change example. Chapter 3 also includes the strategy of learning, the materials needed, the student qualifications and prerequisites required, and gives an example of an assessment and rubric in the book appendix. Chapter 4 discusses anticipated results and benefits of such a curriculum. Overall, one could expect a good reception from students. Improve critical thinking skills from building projects that are problem-solution based, high achievement, and involvement in new extracurricular activities such as the noted Technology Students Association. The benefits noted include the coverage of the STEM subjects, improve achievement test scores, and giving the students examples of applying their knowledge of the course subjects to real-world problem solving. Chapter 5 summarizes the proposal with conclusions regarding curriculum adoption and overall course assessment. It gives recommendations on adding this course to a school's offerings with considerations of forming an advisory group made up of other teachers in science and math and outside community members that have a stake in STEM-related businesses. A pilot program is recommended before full adoption. The recommendation is given that a pilot course be offered over a grading period with a scaled-down curriculum with emphasis on what physical computing is and with limited lab work. The final conclusions in Chapter 5 discuss how this curriculum could be part of a change in addressing the issues of critical thinking, the role of creative thinking in the solution of real-world problems, the blending of the two concepts of thought, and how a curriculum such as this could be expanded into the lower grades.